Void and supervoids are the most horrific regions in the cosmos. Get in your car and drive to a location away from the lights of the city. After that, exit the vehicle, take a few deep breaths, and turn to face the sky. Many stars are easily visible. The first astronomical observation has been made. You only need to open your eyes and be in awe of the universe. No instruments are required. Do you not feel little and nearly empty? All the stars in our galaxy, the Milky Way, are much larger than what you can see with your own eyes. Although you can't see them, the vast majority of stars are part of it. Of course, there are restrictions on our website. Imagine you later discover a deep enthusiasm for astronomy and decide to purchase a telescope. Your ability to see items will grow dramatically. With more advanced telescopes, you can now examine things at ever greater distances and with greater resolution. Astronomers have traveled to tremendous distances thanks to advances in technology, and as they have expanded the range of their telescopes, they have cataloged and mapped every item in the universe. They created a description of our universe. They soon discovered that the universe is completely different from the one we are accustomed to on a grand scale. The Sun and many stars in our galaxy serve as the beginning point, and from there they were able to observe several galaxy clusters that they named groups and clusters. Two galaxies are typically separated by a distance on the order of megaparsecs. For instance, the Milky Way is a member of the Local Group and the Virgo cluster, which has a large number of galaxies, about 1,500, including the Andromeda Galaxy and M87. And the center of the so-called Virgo supercluster is the entire Virgo cluster. This is our universe's purported large-scale structure. The largest known structures in the universe are filaments, which are this waist and the gigantic structures. However, when you travel deeper, astronomers discovered that you also observe a lot of cosmic voids. To learn more about them and the reasons for their existence, watch this video with me. The intro roll: the filaments, which make up the universe's biggest size structures, are separated by immense expanses known as cosmic voids. They have hardly any galaxies, if any at all. However, this does not imply the absence of comets, planets, or stars. In fact, it is a little inaccurate to refer to these formations as voids. Voids aren't completely empty. Instead, they're just very underpopulated, typically containing only 10% of the matter that would be present in a typical region of the universe. When they first encountered a void, astronomers were astounded. In 1978, the first two articles on the subject of voids in the universe's large-scale structure were released. Astronomers were precisely mapping our universe at that time. They found a big hole in the Boötes region of the sky in 1981. One of the most astonishing discoveries of the 1980s, it seemed, had been made. Astronomers first hypothesized that voids might somehow be connected to dark matter. They weren't sure if a void held dark matter, but recent measurements indicate that there are no dark matter halos. Still, there is no dark matter. Nothing is what makes up an emptiness. The fact that voids and supervoids span an estimated 100 megaparsecs, or 100 million parsecs, is what makes them the most unsettling. An empty region of such a dimension would take 325 million years for light to traverse. We have a vacuum in the Virgo supercluster. Our local cluster of galaxies is located on the edge of that vacuum, which is roughly 60 megaparsec long. Galaxies appear to be somewhat repellent by the nothingness, according to observation. This is the situation with the dwarf galaxy SO 461-36, which is situated in the middle of the emptiness yet seems to be heading there. Additionally, the Milky Way appears to be veering away from the nearby emptiness at a speed of 260 kilometers per second. We will cover more of the other significant and well-known voids in our universe later on in this video. What does physics say about them, though? First, it is thought that some baryon acoustic vibrations during the Big Bang led to the formation of voids. In layman's words, these are mass collapses followed by implosions of compressed baryonic matter. The more likely hypothesis is that originally modest anisotropies in the early universe grew bigger in scale over time. High-density regions collapsed under gravity, ultimately producing the massive foam-like structure of voids and galaxy filaments we observe today. Cosmologists still don't have a firm understanding of how these voids in the cosmos could exist. But according to computer simulations, smaller voids, which are significantly more prevalent in the universe, are brought about by galaxies colliding because of gravitational force. This results in the neighboring regions emptying, and because the process is self-reinforcing, it tends to create voids that get bigger and bigger. So, if we were feeling very sentimental, we could explain that voids result from imperfections. Even the Big Bang wasn't flawless. The universe has been flawed since its inception. For instance, the substance was not entirely homogeneous. These minute variations in density, these flaws, produced the filaments and voids that make up our modern structures. The substance was more dense in some areas and less dense in others. Just that. The real puzzle is why that happened. Although we are still investigating, my initial response would be, well, why not? Why might we anticipate absolute homogeneity during the Big Bang? This kind of question is one that scientists are actively working to resolve. Astronomers put a lot of work into studying voids because they seem to be connected to the cosmic microwave background. Voids are an important component of the physical evidence for dark energy. In fact, the cosmos now needs around 70% of the dark energy present for the simultaneous presence of the greatest known voids and galaxy clusters. In the universe, voids resemble sensitive bubbles because they vary with the universe's expansion. The cosmological models that are based on the notion that dark energy is there and that the universe is expanding at an accelerated rate can then be constrained by looking at how they evolve over time. Good work. Our knowledge of gaps is extensive. Let's find out which of them is the most well-known. The first, the vacuum of Boötes. The Boötes vacuum, also known as the Great Void and first observed by astronomer Robert Kirshner and his team in 1981, is a vast, spherical region of space with extremely few galaxies. Its name comes from its proximity to the constellation Boötes and its distance of about 700 million light-years from Earth. The startling discovery was first reported by the researchers in their work titled A Million Cubic Megaparsec Emptiness in Boötes. It is the biggest emptiness in the known cosmos. Astronomers became aware of how extraordinarily barren the region was soon after its discovery. They initially only discovered 8 galaxies spanning the area, but subsequent scans showed that there were actually 60 galaxies there. Even though that may still sound like a lot, it would be the equivalent of discovering things that were 60 miles long scattered across an area the size of the continental United States, and that's just in 2 dimensions. The size of the emptiness, according to astronomer Greg Aldering, is such that we wouldn't have known there were other galaxies until the 1960s if the Milky Way had been in the center of the Boötes void. Astronomers also discovered a well-known emptiness in the Taurus constellation. Circular, 30 MPC across, and close to the Perseus-Pisces supercluster is the Taurus void. Several galaxies, including UGC 2627 and UGC 2629, left, which are located inside it and are located about 185 million light-years away, have been discovered, no larger version. A group of cosmologists from the University of Hawaii discovered compelling evidence in April 2015 that the greatest structure ever seen in the cosmos existed, which turns out to be nothing at all. The Eridanus supervoid, a region of emptiness measuring 1.8 billion light-years across and situated roughly 3 billion light-years from the Milky Way, was suggested to exist by the findings of the Cosmological Survey, which were published in monthly notices of the Royal Astronomical Society. But now for the tricky part. We already know that general relativity operates marvelously at both small and large sizes in our universe. However, is it possible that it fails at very large scales? Be sure to like or dislike the video before learning the answer to this query so that we can keep improving and making these films better for you, the viewer. Additionally, be sure to click the bell to subscribe to the channel so that you don't miss any of our weekly videos. We'll see is the response. The Hubble constant and the matter's energy density are two important metrics that cosmologists use to characterize the universe. For instance, the Hubble constant is described as the ratio of the universe's scalar radius of curvature's rate of expansion over time. As Einstein taught us, these parameters are rigidly constrained by the geometry of our universe, including its curvature and any other aspect you can imagine. Therefore, in a sense, various Hubble constant evaluation results at this time imply a different rate of universe expansion. It also has an impact on how we perceive distance. Our cosmos will either be compressed or expanded by a shift in the Hubble constant. Instead, we can learn something about the acceleration of our cosmos from the acceleration parameter. Since a universe with more mass would accelerate less, it is tightly correlated with this parameter of our universe's mass density. If it helps, visualize possessing a tiny and a large rock. At a meter's distance from you, you want to shove them away. The larger one is heavier and will require more force to move because of its size. Because they link geometrical and dynamical features of the universe, these parameters are extremely delicate. In addition to indicating the larger expansion rate, a higher Hubble constant also has some implications for distances. Additionally, there is a significant issue with voids that we must address. Because of the apparent severe changes in these metrics inside the voids, our comprehension of the cosmos temporarily halts, forcing us to reconsider both the physics and the geometry of the universe as well as its own structure. Void and supervoid behavior truly does seem to follow some cosmic rules that are different from those of the known universe. Because of this, testing models for voids can be done with a great degree of accuracy, and as a result, we can anticipate some intriguing new information from the study of these unsettling locations in our universe. It's also vital to keep in mind that some theories link the cosmic background radiation map and the existence of cosmic supervoid. Some regions on the cosmic background radiation map look warmer while others look cooler. Cold spots are another name for the largest, coldest regions. The light emanating from the farthest reaches of the observable universe, which are 13 billion light-years away, is what makes up the CMB map, and it shows us what the cosmos looked like just after the Big Bang. Since a void has a tremendous length, it takes millions of years for light to escape from it. This stretch becomes even longer due to the universe's ongoing expansion. Vacuums are chilly places, thus the light there is colder and less energetically charged. Nearly serving as refrigerators are voids. Perhaps you could place some beer in a void and see the results. These theories explain why we see some regions of the cosmic background map as being cooler than others. But this isn't due to a sudden drop in CMB temperature, rather, photons are moving across these holes. The coldest light that reaches Earth, not the coldest regions of the cosmic background. Here's where the video ends. Thank you everybody for watching. What are your thoughts on supervoids and voids? Do you believe they will be essential to our comprehension of the cosmos? Tell us in the comments section below. See you on the channel again soon.